In this video, we are going to look at the application of the microcontroller in what is called the embedded system. And when we say application, we are now specifying where this particular microcontroller can be applicable, and in most cases it is applicable in embedded system. And in terms of the embedded system, we can define it as follows. An embedded system is a system where the computer, or we call it the microcontroller, is part of a larger device and is designed to perform a function or a specific task. When we talk about a device, and we can give an example such as a fuel monitoring for a automotive vehicle, and this particular vehicle we can have the wheels, and what we have is called the fuel tank, and we have a dashboard in the front of the vehicle. And we can now be able to see that if we want to design a device that monitors the fuel of this vehicle, and we now can have what is called the fuel tank, and we have the fuel dashboard. Now we have to have the sensors that is responsible for monitoring the fuel, and we can call it the sensor 1, sensor 2, and sensor 3. And we can understand that the sensor 1, sensor 2, and the sensor 3, they all measure, let's say, the full capacity, the midway capacity, and let's say the low capacity of the fuel within the tank. As soon as the fuel is at each of these levels, this particular sensor is responsible to indicate that the fuel is at each of these levels, level 1, level 2, and level 3. We cannot be able to measure the level of the fuel every time, and we want a device that can be able to measure the level of the fuel and give us some representation. And in that case, we have the dashboard, and this dashboard we can be able to see a corresponding fuel level, and we can have some indicator. And this type of dashboard is known as the graphical user interface. It will provide to the person driving the vehicle some graphical view of volume of the fuel inside the tank. And we have the fuel tank and we have the dashboard. To enable the level of the fuel inside the tank to be displayed on the graphical user interface, we now need something called a microcontroller. And microcontroller now have the ability to compute the level of fuel inside the tank and showing it on a graphical user interface. And we can have the input as the voltage sensor level, and we have the output, which is the graphical user interface. And we can select a specific microcontroller. We can call it the MCU, and the output is to the graphical user interface, and the input to this microcontroller will come from, let's say, the level sensor. And this can be the block diagram of the fuel monitoring system. Since this is called a device, we now talk about the embedded system where we have the microcontroller, which is a part of a larger device in a vehicle, such as the tank, the graphical user interface, and the vehicle itself. When we have the microcontroller as part of this type of system is called the embedded system. Anything you want to design later on where the microcontroller is a small part of the larger system, this type of system can be regarded as the embedded system. I will give you some example and we will discuss each of these example about the application of a microcontroller. Some of the discussion you may already know or you may already see and use in your everyday life. And I will give you a block diagram representation and explain each of the process like what we have done with the fuel monitoring of a vehicle. Why do we need to learn those type of application and provide some discussion? This type of discussion will help you brainstorm into your future work. If you are interested in embedded system design, by knowing some of the application and the description that we have available in the market can help you broaden your knowledge into future endeavors to a specific design in electrical engineering. Now we can begin with some common application areas of the microcontroller in the embedded system. The first common application in our list is the consumer electronics. Consumer electronics are electronics devices that people use and purchase every now and then. And we can have A, which is a washing machine. A washing machine can be regarded as an embedded system. We all know that a washing machine may look something like this, where it has a specific task, and this specific task is for washing and, let's say, drying clothes. And this is an electronic system. You will find a switch or sometimes a button which is responsible for the input control. Let's say for washing, and we also have the input control which is responsible for drying the clothes. And this washing machine is a device which is responsible for washing and drying the clothes. And since it has some specific input and the output, where can we have the output of this particular device? It is coming from what is called the motor, and this motor is regarded as the output of this particular device, and this device is an embedded system. And now we have the microcontroller, which is responsible for getting the input information such as washing, drying, and it will process and control the motor to achieve the desired input. As soon as the washing machine is switched on, this washing machine will wait for the input, and the user will select those input either for washing or drying. If the button for washing is pressed, then this microcontroller will generate a signal to control the motor. And this type of algorithm can be a conditional statement, and we can say if this microcontroller is programmed with this type of algorithm, and if the user select the washing, then the motor will be on, and else we can say the motor will be off. And this can be a simple algorithm that will be used to control the motor. And we can clearly see that this is a type of embedded system, and it is made up of the microcontroller that will control the entire process of washing and drying of the clothes. And secondly, we can discuss the microwave oven. B, we can have microwave oven, and this oven can be found in most houses. And the function of the microwave oven is to, we can say, heating of the food. And the microwave oven can also be seen something like this, and this is where you insert your food inside the microwave. And how the food is heated is by using a microwave signal, and we have a button which will turn the microwave on or off, and we have what is called a timer, and this timer is responsible for the time it takes for the microwave to eat the food. And inside this microwave, the control is provided by a microcontroller, and we can have the input signal such as on or off, and we can have the timer. And those are the two important features of a microwave oven. And the output will be the microwave heater. So a microwave heater is a device that is used to produce the microwave signal, and this microwave signal can be seen as the energy that is applied to the food. And it can have a simple algorithm since it is made up of a microcontroller which acts as the brain of this microwave heater, and we can be able to program. And let's say if the power is on, then it will wait for the timer to be switched on, and we can be able to see that if this condition is true, it will wait for the timer. So let's say if timer is equals to 5 minutes, now we can have the statement which says the microwave heater must be switched on for 5 minutes. And let's say else, we can say wait for timer. And else we can be able to say that microwave is off. And this can be a simple algorithm that is used to control the operation of the microwave. Now, when the microwave is switched on, it will wait for the timer to be switched on. And if not, the microwave is off. And we can see that under the timer syntax, the system will always wait for the timer to be set, such as 2 minutes, 3 minutes, 5 minutes, 10 minutes, or 20 minutes, depending on the type of food you insert into the timer. And if the microwave is not switched on, then automatically the microwave is switched off. And since this microcontroller is part of a larger system, we can now call this type of system embedded system. I hope with those examples you can be able to appreciate why microcontroller is used in many of our consumer electronics. And finally, under consumer electronics, we can discuss, let's say, smart TVs. I will now briefly explain the smart TVs and how microcontroller is used in those TVs. In our modern days, we have the digital television. Previously, we have what is called the analog television, and we have some specific control of those analog TVs. In our current age, we have the smart television, and because of digital electronics, which becomes more and more popular in our today's world, we now control this television using binary, and it is mostly 1 or the zeros. And for this television, we have a control, and it is mostly controlled using a push button or a capacitive sensor, and we can have those buttons which indicate different operation, such as the on or off of this television, and we have the channel selection, and we can have the volume plus or minus to increase or decrease, and we can have some system, let's say, setting. And with the ability of a push button, we now can have a microcontroller where all this input will definitely coming from those buttons, and the output of the television is mostly the display. Upon selecting each of these buttons, such that when the TV is on, it will now be able to process all the settings like the channel selection, to increase or decrease the volume, or set the display or other specific setting of this particular television. And in terms of the channel selection, we can be able to have what is called the encoder. As an example, I will give where we have multiple channel as an input, and the output will be to our television display. And we normally have some select lines which control which of this channel can be passed to our display. We have the digital electronics course where we discuss some of these particular devices, such as the encoder, and how to control the encoder to select a specific channel to be displayed on a television. And since this television is made up of a very complex system, we can have this microcontroller to control the select lines, and these select lines will be coming from the channel selection. When we select a specific channel, now this microcontroller will be able to send a specific bit to the select lines to select which of this specific channel to be displayed on our television. And the volume plus or minus, which specify the increase in the volume or decrease of the volume, can be found with the microcontroller itself, where we can say if in terms of the algorithm is volume is plus, then it will increase, let's say, the volume. And we can say else if the volume is minus, now we can have the decrease in the volume. And we can appreciate that this microcontroller is responsible for controlling most of our consumer electronics. And with this discussion, I believe it should help you appreciate how those consumer electronics are made and why we need to learn microcontroller and their. Thank you for watching our video. Kindly subscribe to our channel and share this video with your friends so they can also be able to learn.